So you've got all this data, right? It's everywhere. It's coming from our phones, our cities, from pretty much everything. But the big question, the one every single AI developer hits right at the start is, okay, now what? How do you take all this raw, messy information and actually turn it into something smart? That's the puzzle we're going to piece together today. Okay, so here's our game plan. First, we'll dig into why data is the absolute foundation of any AI. Then we'll get our hands dirty with a really famous data set to see how this all works in the real world. From there, we'll break down what data is actually made of, its basic building blocks. Then, the really fun part, how to spot those patterns hiding in plain sight. And finally, we'll wrap it all up by talking about how to get that data perfectly prepped for an AI to learn from. And just to set the stage here, we are not talking about a little trickle of information. As this quote points out, with all these little devices we use every day, all connected to the internet, the amount of data being generated has it's gone exponential. It's an absolute explosion. So think less gentle stream and more tidal wave. Seriously. And if you're working in AI, figuring out how to ride that wave instead of just getting swamped by it, that's everything. Which brings us right to our first stop, understanding why data is always step one. I love this analogy. Think of an AI model like a brand new high-performance race car engine. Super powerful, right? But you're not going to pour dirty, unfiltered fuel with gunk in it into the tank and expect it to win a race. Of course not. Well, raw data? That's kind of like the dirty fuel. It's got all the potential, but it's messy. You got to refine it first. And that whole refining process, that has a name. It's called data preprocessing. You see it right here. It's basically the most important housekeeping job in all of AI. It's like a chef meticulously prepping all their ingredients before they even think about turning on the stove. It's all about cleaning and organizing, turning a chaotic mess into a solid foundation. Because if you skip this step, you don't get intelligent insights, you just get noise. All right, enough theory. Let's make this tangible and get our hands dirty with a true classic. We're going to explore the iris flower dataset. This thing is a cornerstone of machine learning education, and trust me, it's the perfect case study for what we're talking about. So, what's so special about this iris dataset? Well, as you can see, the goal is super straightforward. Can we classify 3 different types of iris flowers just by using a few simple measurements? We've got 150 samples, and here's the best part. The data is clean. There's no missing info, it's all just numbers. This lets us cut right to the good stuff without getting bogged down in a bunch of cleanup work first. Here's a little peek at the data itself. See, each row is just one flower, and for each flower we have 4 measurements. The whole game, the entire challenge for our AI, is to look at those first 4 columns, the numbers, and learn how to correctly predict what's in that last column, the flower's species. That's it. And that, right there, is a classic classification problem in a nutshell. Now, to really get a handle on any dataset, you gotta learn to speak its language. And that starts with 2 fundamental building blocks, 2 words you absolutely have to know: entities and attributes. Let's break them down. First up, the entity. It sounds a little fancy, but it's not. An entity is simply the whole thing, the entire collection of related data. It's the whole spreadsheet file, or the complete database table. So in our case, the entire iris dataset with all 150 flowers, that's our entity. Now, inside that entity, we find the attributes. These are just the individual pieces of information, the different characteristics we're measuring. In a table like this, an attribute is just a column. That's all it is. So sepal length is one attribute. Petal width is another. Simple as that. So let's put it all together for our example. The entire iris data file, that's the entity. And each of those columns, sepal length, petal width, and so on, those are the attributes. And honestly, if you can get that simple distinction down, you've already unlocked the ability to understand the fundamental structure of pretty much any dataset out there. Okay, so we understand the structure. Now for the really cool part. How do we find the patterns that are hidden inside all those numbers? Because that's where the magic happens. And it turns out it's all about looking at the data from the right perspective. But hang on a second. Here's a tricky question. Our brains are wired for a 3D world, right? We see length, width, and height. So how can we possibly visualize data that has 4 different attributes? Each flower is like a single point in a 4-dimensional space. I mean, how do you even begin to see a 4-dimensional flower? It kind of breaks your brain if you think about it too hard. Well, this is exactly where machine learning comes in and just shines. While we can't see in 4 dimensions, an algorithm has no problem with it. It uses some pretty clever math to essentially test thousands of different perspectives on the data. And as you can see here, from the wrong angle, the data is just a jumbled mess. The flowers are all mixed up, but if it finds just the right perspective, the right angle to look from, bam, the 3 flower types just pop out, suddenly becoming these clearly distinct and separable groups. And this illustrates a core idea in data science perfectly. It's not just about having the data, it's about finding the ideal viewpoint that reveals its hidden structure. The goal is always to simplify the problem, to make it as easy as possible for the AI to find a solution.
This brings us to our final section, where we tie everything together. Understanding the structure, finding the patterns, it all leads to one crucial goal: preparing our data so it's finally ready for a machine learning model.
You can think of this whole process as a kind of data pipeline. First, you understand the basic structure, your entities and attributes. Then you visualize it to find those hidden patterns. Next, and this is critical, you clean the data. You have to iron out all the weird spots, fixing typos, dealing with missing values, and spotting those strange outliers, like a flower with a petal width that someone accidentally typed in as 20 centimeters instead of 2. Finally, you prepare it, formatting it in a way that's perfectly optimized for an AI to learn from. Each step is absolutely essential. And look, if you only remember one thing from this whole explainer, make it this: garbage in, garbage out. It's the golden rule of AI. You could have the most advanced, most expensive AI on the planet, but if you feed it messy, unprepared data, you're going to get useless results. Data pre-processing isn't just a warm-up. It's the foundation that everything that comes next is built on. So, I'll leave you with the final question to think about. We're often captivated by the powerful algorithms and the incredible answers AI can give us. But if the quality of those answers is entirely dependent on the quality of the data we start with, which is truly more important, the algorithm or the carefully prepared data that fuels it?